All right, so 5th grade lesson 7.3 into math. Assess reasonableness of mixed number sums and differences. As we add and subtract mixed numbers with unlike denominators and assess reasonableness. Step it out. Carolyn trains every weekend for a track and field competition. She writes down how long she spends running sprints and jumping hurdles. How many hours does she spend training on Saturday? Or Sunday, sorry. So kind of looking over here, probably a better picture on your guys' paper than on my copy paper, okay? But so it says for sprint, she does how long?
2 and 2 fifths.
2 and 2 fifths an hour, and then 1 and 1/4, right, for hurdles. So what would our expression be? 2 and 2 fifths plus 1 and 1/4, right? Okay. So they want us to estimate our answer. Okay, since we're using time, so for 2 and 2 fifths, is that closer to 2, 2.5, or 3? 2.5, right? Plus 1 and 1/4. Okay. Now 1/4 is right in the middle of 1 and 1/2, right? But since we're using time, you probably want to be a little bit on the higher end, right? Okay, just so you make sure you cover it all. So we would estimate that to 1 and 1/2. So 1 plus 2 is 3, and then half plus half is 1. So about 4 hours, right? Rewrite the expression in part A using an equivalent fractions with a common denominator. Then find the sum. So we're going to work over here to the side. So 2 and 2 fifths plus 1 and 1/4 equals. So our whole numbers stay the same, right, guys? What's going to be our common denominator of 5 and 4? 20, okay? How did I get from 5 to 20? Times 4. What I do on the top, I do on the, or what I do on the bottom, I do on the top. So 8 20th, right? How did I get from 4 to 20? Times 5. What I do on the bottom, I do on the top. So 1 times 5 is 5. Okay. So 8 20th plus 5 20th is 13 20th. And 2 plus 1 is 3. Okay. So basically our work is kind of over here, right? To give us a little bit more room. So how many hours does Caroline spend training on Sunday?
3 and 13 20th hours.
So 3 and 13 20th hours. So is your answer reasonable? Explain. So yes or no? So yes, because 3 and 13 20th is between what? Is between 3.5 and 4, right? Is what's half of 20? 10, right? So 13 is between 10 and 20, right? Okay. So is between 3.5 and 4. Pole vault jump is 7 and 1/4 feet. The sign in the gymnasium shows the gym's record. How much shorter than the gym's record is Jonah's best jump? Okay, so his is 7 and 1/4 feet. Okay, and they want to know how much shorter it is. So that, what's the record? 8 and 7/12, right? Okay, so what am I going to write? Are we going to add, subtract, multiply, or divide? Subtract, right? Okay, and then which one goes first? 8 and 7/12 minus 7 and 1/4 equals. Okay, so estimate our answer. Okay, so 8 and 7/12, is that closer to 8, 8.5, or 9? 8.5. And then minus, is that close, 7 and 1/4, is that close to 7, 7.5, or 8?
7.
We could do 7, or you can do 7.5. Okay, so you guys want to do 7 this time? Okay, equals 1 1/2. Okay. So if we did 7, it would be 1 1/2, right? If we did 7 1/2, it would be 1, right? So anywhere from 1 to 1 1/2 feet difference, correct? Okay. Oh, I hit feet. Okay, rewrite the expression in part A using equivalent fractions with a common denominator. So we have, let's work it out over here. So 8 7/12 minus 7 1/4. So what is going to be our common denominator? 12. So we can just rewrite 7/12, correct? And then 7, and then something over 12. So how do I get from 4 to 12? Times 3. So 1 times 3 is 3. So 7/12 minus 3/12 is 4/12. 8 minus 7 is 1. Okay, is that in simplest form? No. So 1, what goes into 4 and 12? 4, right? 4 goes into 4 once, 4 goes into 12 3 times. So how far is Jonah's jump from the gym's record? So 1 1/3 feet. And then yes, because 1 1/3 is close to 1 1/2 feet. Okay, so for understanding, Jenna competes in the high jump. Her best jump in the first meet is 4 1/4 feet. Her best jump in the second meet is 4 5/6 feet. Write an expression using equivalent fractions with a common denominator to model how much the height of her jump increases. By how much does the height of her jump increase? Show that your answer is reasonable. So we're going to show an estimate first, and then we're going to get the actual answer. Okay, that makes sense? Okay, so we have the 4 1/4 feet, and we have the 4 5/6 feet. Okay, so do we need to add, subtract, multiply, or divide? Subtract, right? It does talk about increasing, but we need to show the difference, correct? Okay, so what am I going to do? 4 5/6 minus 4 1/4. Okay, now let's do our estimate real quick. So that could also be what? So 4 is it 4 times 6? Is that close to 4, 4 1/2, or 5? 5. Okay, so 5 minus, and then 4 1/4. Is that close to 4, 4 1/2, or 5? Let's go ahead and go with 4. You think that'll work? Okay, so you have at least 1 inch, right? If we would have done the 4 1/2, that would have only said 1/2 inch, right? So we want to give us a little bit of wiggle room. Okay, so what is my common denominator between 6 and 4? 12, right? So our whole numbers stay the same, correct? Okay, how do I get from 6 to 12? And guys, while they're working over there, it's okay, right? We might hear some of that in the background. So 6 times what gets us 12? Times 2. So 5 times 2 is 10. Okay, 4 times what is 12? Times 3 gives us 12. 1 time, so we do on the bottom, we do on the top. So 1 times 3 is 3. So 10/12 minus 3/12 is 7/12. And then of course 4 minus 4 is 0, so we don't have to put that. So is 7/12 close to 1? Yes. Or it could have been close to 1/2, right? If we would have done 4 1/2. Okay. So 7/12 foot. Okay. And then we showed that our estimate is close to our answer. Okay. Number 2. Write an expression using equivalent fractions with a common denominator to find the sum or the difference. So I'm going to write over here. So 2 3/5 plus what, guys? 1 3/10. So what is my common denominator? 10. So 2 and something over 10. The bottom one, do I have to change? No, because it already has the 10 on there. How do I get from 5 to 10? Times 2, what I do on the bottom, I do on the top. 3 times 2 is
6.
So 10 plus 3 tenths is 9 tenths. 2 plus 1 is 3. Is that simplified? Yep, so that is our answer, 3 and 9 tenths. Correct? Okay, number 3. What's our problem? 3 and 7/8 minus 1 and 1/2. Okay, what's my common denominator? 8. So I don't have to change the top one, right? Okay, this next one is 1 is my whole number, 8 is my denominator. How do I get from 2 to 8? Times 4. What I do on the bottom, I do on the top. 1 times 4 is 4. Okay, so 7/8 minus 4/8 is 3/8. And then 3 minus 1 is 2. Is that simplified? Yes. So I can circle it and go on. On her own, Donna trains for a triathlon. Her fastest times for the 3 parts of the event are swimming, 1 1/4 hours, running, 1 1/2 hours, and biking, 1 1/5 hours. If she matches her best times in all 3 parts, how long will it take her to finish the triathlon? So here's our numbers. Okay, so they want to know how long it will take her to finish it. So what am I going to do? So I'm going to add, subtract, multiply, or divide? Add. So 1 1/4 plus 1 1/2 plus 1 1/5. So what is the least common multiple of 4, 2, and 5? 20, right? So you keep the 1, something over 20. Keep the 1, something over 20. Keep the 1, something over 20. How do I get from 4 to 20? Times 5. So I do on the bottom, I do on the top. 1 times 5 is 5. 2 to 20. Times 10. I do on the bottom, I do on the top. So 5 times what? 4. I do on the bottom, I do on the top. So 1 times 4 is 4. So 5 plus 10 plus 4 is 19. And then our denominator stays the same at 20. 1 plus 1 plus 1 is 3. So it would take her 3 and 19/20 hours. Attention to precision. Richie estimates 1 7/8 minus 1 1/6 to about 1. But he finds the actual difference to be less than 1. Did he make a mistake? Explain. Okay, so because he estimated the 1 7/8 to 2, right? And the 1 1/6 to 1. Okay, and then, but did he make a mistake? No, so he didn't make a mistake. It's just we were only making an estimate, right? So sometimes, so Richie did not make a mistake. Since he was making an estimate, comma, the actual answer can sometimes be a little lower or a little higher.